Good morning, students. Welcome back to the session. Today class, I'm going to start with a new chapter. In the 8th class, in our textbook, we have 12 chapters. How many chapters we have? 12 chapters. Out of 12 chapters, the government has deleted few topics. Okay. And up to 6 lessons, I explained clearly. Now coming to the 7th chapter. What is that 7th chapter? Coal and petroleum. Then after chapter 8, there is the combustion fuels and flame. So these two chapters are deleted. These two chapters are deleted. Then the next chapter is 9th. So after the 6th chapter, immediately I have to start from the chapter 9 because these two chapters are deleted by the government. Some of the portion was deleted. So these two lessons comes under the deleted portion. Now coming to the chapter 9. Before going to start this chapter, I'll start with the introduction. In the 4th chapter, what is the name of that 4th chapter? Metals and non-metals. In that we have discussed about physical properties of metals and non-metals. So what are the physical properties of metals? Sonority, ductility, what is that? Sonority, ductility and electrical conductivity, heat conductivity. We have discussed different properties. In that, one of the property is electrical conductivity. What is that? Electrical conductivity. Here first, once again, I will explain what is conductivity. You see, in this already I explained about the electrical conductivity. In that all the metals are good conductors. All the metals are good conductors. What is the meaning of conductors? Generally we have different types of conductors: good conductors, bad conductors, or we'll call it as poor conductors, and semiconductors. So what are these conductors? We have different types of materials. In that, some of the materials are allowing the current to pass through them. For example, when you switch on, fan works, so it is a good conductor. Why? Because that from switch to fan there is a connection. In that connection, it was given through the wiring. Means it is a metal. So these metals are allowing the current to pass through them. Due to that, the fan is working. So it is a good conductor. And if you take the iron box, when you switch on, immediately it is getting heat and you can press the clothes. So this is also an example, because in that it is allowing the current to pass through it. So it is also a good conductor. And some of the bad conductors are there. What are that? In that wiring process in the houses, we are using the metal wires like a copper wires. But we are not using any wood wiring or any plastic wiring. Why? Because that materials, they're not allowing the current to pass through it. So that's why they're the bad conductors. So from that, you are clear about what are the good conductors and bad or poor conductors. Now coming to the electrical conductivity, means the materials which are allowing the current to pass through it. They are the electrical conductors, are the same. Now, in electrical conductivity, for that we have that small circuit you have to prepare. What is that circuit? The arrangement of the things, and you make it as a close. Here you see, this is the cell, means battery, you take it, and from the battery to two conducting wires. Conducting wires means they should allow the current to pass through it. Understand? And here one bulb, and here the two terminates. You leave the gap between these two terminates and use different materials in this gap, like iron nail you take it, and straw you keep it, and eraser you keep it, like paper you place it, like different materials you place it in between these two terminals, and each time you observe that the bulb glows or not. Now first we'll discuss. First one is we will take the iron nail. If you take the iron nail, then the circuit is completed. Means there is no gap between the circuit. Then we'll call it as a closed circuit. We'll call it as a closed circuit. When the circuit is closed, then you observe whether the bulb glows or not. Obviously the bulb glows. Why the bulb glows? Because from this cell through the wires, the current is passing through this nail. Means the nail is allowing the current to pass through it. Due to that reason the bulb glows. So this is a good conductor. So we'll write it as good conductor. Next, instead of nail, you take it to this nail and you take one straw. Just you place it in that gap, a piece of straw, and you observe. Then bulb glows or not. Actually the straw is made up of plastic. So plastic are bad conductors. So if you take the straw, bulb does not glow. So it comes under bad conductor. Next, you know the pencils in between, that point is there, na black point, that is made up of graphite material. That is made up of graphite material. So that lid you take and place it in between these two gaps. So the third one is graphite. So that lids are available. So take that lids and place it and observe bulb glows or not. Actually, we discussed about the all metals are good conductors, but the graphite is not comes under a metal. Even though when you place it the graphite, the bulb glows. So graphite is a good conductor. Graphite is a good conductor. And next, you take a small wood piece and place it. Remove this straw and take a small wood piece and you see bulb glows. No, wood is a bad conductor. That's why while the electrician, while repairing the switches or any doing the work, either he will use the plastic chair or the plastic chapels, because to avoid the shock. Wood, bad conductor. Next, you take different things like this and place it in between these two terminals, and each time you observe whether in each time bulb glows or not. If you take the metals like copper, iron, aluminum, these are the best electric conductors, and we have different metals, but out of these iron, copper and aluminum are the best electric conductors. So this is like this, you have to test and with the different materials. In all these materials we have taken only the solid substances. We have taken all the solid substances, and out of that solids, some are the good conductors and some are the bad conductors. So what are the good conductors? Almost all the metals are good conductors, and one more is graphite is also a good conductor, like straw, eraser, this pen, pencil and wood, paper. You take different things. So these are all comes under bad conductors. Now here we discussed about the all these are solids. So in that solids, some of the solids are allowing the current, some are not allowing. Now the you know that matter exists in three forms. What are that? Solids, liquids and gases. Now we have checked with the solids. So solids are allowing the current, few solids. Now take the liquids, and these liquids, take different types of liquids and apply the same. What is that? Whether the liquids allow the current to pass through them or not. So what is that? Electrical conductivity of liquids. So this is our topic. Today I am going to explain about this chapter, that is 9. What is the chapter 9? Electrical conductivity of liquids. See, I will give you one example. I think you might have heard in the news, in the TV news, that farmers, some of the farmers died by getting the shock by when they are touching these motors and something. And one more precaution also. What is that? We should not stand near the electric poles when it is raining. And we should not touch, and one more is, we should not touch the electric heaters with wet hands. Even in our home, we should not touch any electric appliances with wet hands. Maybe elders used to give cautions to the kids. Why? Because water comes under liquid. Water comes under liquid. When you touch with wet hands, what happens? You may get shock sometimes. Why? Because water is a good conductor. Water is a good conductor, and due to that, and even our body is also a good conductor. Current is passing through our body. Because of that, sometimes when you get shock, you may get injured, or sometimes you may get a fatal also. Now we'll discuss about electrical conductivity of liquid. For this we have one activity, so I will explain the activity. For this activity 2, electrical conductivity of liquids, you have to take one injection bottle's cap. It is made up of rubber. So you take that cap. Okay. From that cap, you have to take insert two rods. That these two metal rods acts as electrodes. Electrodes means, generally for the current connection we need positive terminal and negative terminal. So for this you take just fix two electrodes like this. From this electrodes you have to give the connection, wiring connection to the bulb. So from one wire to I will see figure from the textbook. This is the figure given in the textbook. See, this I will explain. And from this to LED bulb, and from this bulb to battery, and from this terminal to like this. This is the arrangement. Now we are going to discuss about the electrical conductivity of liquids. So for this, first we have to prepare the tester. What is the meaning of tester? Tester means, generally the electrician, he will use the tester like this pen, and he will keep in the gaps of that switch, and he will find out whether in that gap that electric current is flowing or not. So how he will find out? In that tester there is an LED bulb is there. So this LED bulb glows. When the bulb glows, that connection is working. If the bulb does not glows, then there is a problem in that connection. Like that he can identify. And why they are using only the LED bulb? Even in the smartphones, in the cell phones, and even in TVs and even watches, nowadays they're using the LED bulbs. What is the advantage of this LED bulb? Actually, LED bulb means it has two lids. This is in the LED bulb, it has two lids, and these two lids, one is long, other one is short. So this long one represents for the positive terminal and this is for negative terminal. When you use the LED bulb in the connection, even in that circuit, if a small amount of current flows in the circuit, then LED glows. But other bulbs, if you take, they required more current. But LED means even the small amount of current is flowing in the circuit, it shows by glowing the light. So that's why they're using this LED bulb nowadays, even in the cell phones, watches, TVs, in all. uh, so now for conductivity of liquids, first you have to prepare the tester. So how to prepare? First you take the injection caps, like rubber caps you take it, and in the two electric wires you take, metal wires, just you fix in the middle of the cap, and these two should not touch, and these two conductors, electric wires, should not touch each other. Then from one wire to bulb, LED bulb, from the LED bulb to the cell, cell means battery, and from the battery to the another terminal. Okay, now just you on the battery, so circuit is completed, just you check it whether the bulb is glowing or not. Generally the bulb does not glow. Why? Because the circuit is not completed. Here there is a gap here. Actually current is flowing from like this, like this, like this to here, but from here to here there is no connection. There is no connection. So that's why bulb does not glow. So just if you make it to press these wires to touch like this, then you observe, immediately bulb glows. Immediately bulb glows. So this is the tester, becomes the tester of our activity. Now remove this, and as usual you keep the wires like this only, that two metal rods like that only. Now you take different liquids, you take plastic glasses, and you collect water. Generally will drink water, so drink that drinking water or tap water you collect, and distilled water, lemon water, milk, vinegar, like different liquids you collect it. So first take the glass, in that first you take the distilled water. What is distilled water? Here I will write. What is distilled? Normal water, we have different types of waters: pure water, distilled water, normal water, tap water, like that we have. So what is the special of distilled water? This we are using in the what are that, when current gone, we are using that, I forgot the name. So in that they are using this. Distilled water means it does not contain any impurities or any salts, means pure water. Distilled water means pure. Generally water means it contains minerals, salts, they contain something, but distilled water means that water does not contain any minerals, any salts. It is the pure water. Okay, so take this distilled water, and make sure that these two electric metal rods should dip or should touch in the distilled water, and you observe. Then when you dip in this distilled water, then the bulb does not glow. The bulb does not glow. Then remove this. Then remove this distilled water and bring normal tap water. Normal tap. But while you are doing this experiment, each time these metal rods you must wipe with, make it dry. Means you just wipe with tissue papers or something. Then again you take normal tap water and you make sure that these two should touch in the liquid or dip in the liquid, and you observe normal tap water. Drinking water. Then if you observe that bulb, the bulb glows. The bulb glows. Then next, lemon water you take. Lemon water you take and see, the bulb glows. Next you take vinegar. Vinegar is available, that liquid. So take vinegar and you observe, the bulb glows. And sugar water you take. In the glass you take sugar water and observe. Then bulb does not glow. Just it blinks, but it does not glow. It does not. Make sure each time when you are changing this liquid, each time you must wipe these rods with the tissue papers. Means you should not make it wet, it should be dry. Then the dried one you should place it in the next liquid. Sugar water, the bulb does not glow. And milk you take, does not glow. And like different liquids you take, and each time just you try this one and observe the bulb glows or not. Here one table is given in our textbook. You see here, this is the distilled water. Distilled water, bulb does not glow, means it comes under bad conductor. Next one is drinking water. Next one is drinking water. So drinking water means bulb glows, so it comes under good conductor. Next, third one, coconut oil. So take in that coconut oil and observe. Even the coconut oil also, in the coconut oil also bulb does not glow, so it comes under a bad conductor. Lemon juice. Lemon juice, bulb glows, so it comes under a good conductor. Next, vinegar. Vinegar, bulb glows, so it comes under a good conductor. Next, kerosene oil. Bulb does not glow, so it is a bad conductor. Next, cooking oil you take. Generally for cooking purpose we'll take the oil, so that oil you take and absorb here. So vegetable oil. Bulb does not glow, so it comes under a bad conductor. Next, sugar solution. Next one is sugar solution or sugar water. So bulb does not glow, so this is a bad conductors. It is a bad conductor. So by using the liquids, if you test, some of the liquids are allowing the current to pass through it, and some of the liquids are not allowing the current to pass through it. So here what are the good conductors? Drinking water, lemon juice, vinegar, and that only. So these liquids comes under good conductors and the remaining comes under bad conductors. So today I will stop this chapter here, and next video I will continue the topic. Thank you.